Okay, so this is my solution for both the problems that were given to me from the last energy and momentum problem set. So I'll try to cover all of this in one semi-short video. So I wrote all of my given values here, and I also wrote my free body. I also drew rather my free body diagrams. And I basically looked at some of our previous lessons, and I also looked at some of the homework questions that I had done during my study time, and I realized that this was probably the most accurate equation. At first, I was accounting for the angle mg sine theta over x. I realized that wasn't as necessary, so I realized that I could just use the time to actually find the spring coefficient, in which I got 8.65 newtons per meter. Yeah, I just explained it briefly here on how I got that, and then I even did the dimensional analysis, and that was successful as well. So for the mechanical energy, I just used the classical equation. So mechanical energy equals half ka squared, which was the a being the amplitude, and k being the coefficient that I developed in one of the earlier steps. And overall, I got around 0.10 joules for my value. And essentially for part D, where we talk about how we get rid of those four masses out of the 400 gram cart, I used the same exact equation as before. Instead, I just removed the four masses that were each 100 grams, and then because I already had developed my k value, I actually just plugged that in, and then I figured out the time, and then once I figured out the time, I inferred that frequency was one cycle over the time period. So once that happened, I got 0.74 hertz as my result. And then I also just very neatly wrote my graph as well as my explanation for why the cart actually jumps over, which is pretty clear, if I do say so myself. So if there are, essentially what I write here is, unless it gains velocity over time, then there wouldn't be an increase in kinetic energy. There would always be a decrease. And because this system is being held by a spring, that results in no velocity being changed. So essentially with these masses being removed, you just have a smaller amplitude and a shorter period, but you'd also have a higher frequency due to that mass being reduced. And once again, here's just my graph. So if we move on to the second question, this is fairly straightforward, a lot more simple, if you ask me, as opposed to the first question. This was just a very straightforward inelastic collision question, in which we had to know that the pellet, or the M&M bullet rather, coming out of the pneumatic gun, was once it hit the actual cart, it was moving with it. So that basically means that the final velocity of the cart and the M&M were identical. So once that was accomplished, so the way I actually solved for that was just using the distance and time, using the frames and using the 15 centimeters to actually determine this right here. And once again, I say here that this question is based off of an elastic collision, and looking at my equations that I used in the homework and in the presentations, I developed this. And because the initial velocity of the cart is 0, because it is stationary, then this entire value here is canceled. And since we're solving for the initial speed of the bullet, then that just works out to be 108.6 meters per second, approximately. And basically, this question here asks why the cart jumps up, and that is because of the angle in which the M&M was actually shot out of the pneumatic gun. And obviously the gravitational force has its own effects on this cart, which is why it helps out with the jump. And part of the reason is because the M&M also didn't hit at the center of the mass of the actual cart, which is why we see a little bit of an imbalance, which led to the cart having a little bit of a jump, rather. So in conclusion, yes, I discussed here that the M&M was shot at a point above the horizontal, right? If we look at a free body diagram of the actual cart, we realize that the M&M, once it is hit the cart, it isn't actually hit directly in the center of mass. So if it was, then we'd experience much less of a jump or no jump at all, really. So in conclusion, those are just my 2 solutions for the questions. Hope that was clear and concise. Thank you for listening.